Alright, let's now recall some concepts on adding, subtracting, multiplying, and dividing radical expressions. Let's look at operations with radicals. Operations with radicals. Alright, now with adding, subtracting, that's not too bad. Basically, that's just combining like terms. So here's what I mean by that. Let's recall a couple of square root problems we've done in the past. Let's say I give you something like 5 square root of 27 minus 2 square root of 75, for example. All right. Well, the first thing we're going to do is what? We're going to simplify these radicals and then see if they are like terms or not, so we can add or subtract their coefficients. So let's simplify root 27. That's 9 times 3. So with the 9, then what? 3 can come out of that. Root 9 is 3, right? So we have 15 square root of 3. This extra 3 left on the inside, excuse me, right? And then with 75, it would be 25 times 3. So you want a perfect square as the first factor here again, highest perfect square possible. We call that concept. But 5 coming out of that, so you get minus 10 square root of 3. So are these like terms? And the answer is yes, they are like terms. Because like terms for radicals means same radicand, the same number inside the radical. Same radicand. So that means what? They both have 3 inside the radical, so they're like terms. We can subtract 15 and 10. That's 5 radical 3. Okay, so simply simplify the roots and then see if you have the same radicand inside. If you do, then they are like terms, and you can finish off the problem. Let's go and try another one. Let's take a look at something like 5x square root of 8x, all right, plus 7 square root of 50 x cubed. All right. Again, simplify each of these square roots again. 4 times 2 for the 8, so 2 coming out. This x stays inside. I only have one of them, right? So that x stays inside. So I have 10x on the outside, and square root of what? 2x inside, right? 50, I look at that as 25 and 2. All right, so 5 coming out of that. What about x cubed? I can take out 1x. There's an extra x left inside. If you recall how to simplify that, that's 3 divided by 2. I simply take the power divided by the root index. For square roots is 2, right? That's 1 remainder 1. So 1x comes out, 1x stays inside. So you can have 35x, so plus 35x, 7 times 5, right? 35x on the outside and 2x on the inside. So yeah, they're definitely like terms again with 2 x's on the inside on both of them. Same radicand. Just combine the coefficients here. So 10x plus 35x is what? 45x square root of 2x. Alright, so again, not too hard if we simply simplify the square roots carefully, simplify these radicals carefully, if you will. Let's go ahead and try another one. Let's take a look at a cube root problem here. Let's go and clear out the screen here. So it comes down to being able to simplify these types of radicals. Let's look at 4 times the cube root of, let's say, 54 xy cubed. Alright, minus 6 times the cube root of 2xy cubed, and plus 9 times the cube root of 128 xy cubed. Alright, so again, start by simplifying these cube roots first, and then see if you have the same radicand inside, which makes them like terms, and we can combine their coefficients. Alright, so same deal as before. So the hard part is simplifying these radicals. Easy part is really combining the like terms, combining the coefficients, that is. Alright, so let's look at 54. I'll look at that as 9 times 6. 9 times 6 here, which is 3 times 3 times 3 times 2. So a triplet here, looking for 3 of a kind, right? So 3 can come out of that. Alright, this x stays inside, but y cubed, I'm going to take a y out. And there's no y's left inside since the remainder is 0 if you take 3 divided by 3, right? So what you have here is going to be what? 4 times 3 is what? 12 times y, so we have 12y cube root of what? 2 inside, and what else? X inside. Cube root of 2x, alright? Let's look at the second one. Well, that's pretty easy. Just take out the y in that case. Again, 2x stays inside, so you have 6y times the cube root of 2x inside. So far these two are like terms, as you can see. What about the 128? Let me try 64 times 2, which is going to be 4 times 4 times 4 times 2. So again, we've seen 64 before, right? So triplet is 4. So we take a 4 out of that. Again, we have y cubed, take a y out, and this x stays in. So we're going to have what? 36y plus 36y times the cube root of what? 2 on the outside and x on, so 2 here and x here, so 2x on the inside. Sorry about that. So you can see again, you have 2 x's as the radicand, and so they are like terms, just combine their coefficients. 12y minus 6y is 6y plus 36y is going to be what? 42y cube root. Again, need to put the root index here. If you leave off the 3, you're saying square root, which changes the problem, right? So this 3's got to be there. Cube root of 2x. Okay, so that is the solution we're looking for in terms of simplifying these cube roots carefully here, right? Let's do one more here. What about let's try 3 times the 4th root. So let's try 4th root here of 32x to the 5th plus 2x times the 4th root of 162x. 162x. Alright? So again, simplify these 4 roots carefully. Simplify the radicals carefully again. 32 is going to be 8 times 4. Alright? That's going to be 4 times 2 times 2 times 2, or 2 times 2 times 2 times 2 times 2, right? For these 2's for the 4 right here. So 4th root, we're looking for what? 4 of a kind. So we have 4 2's here. 1 can come out. This extra 2 stays inside. X to the 5th, I can take out 1x with an extra x left inside. So this is going to be 6x on the outside, 3 times 2x, right? So we have 6x on the outside, and you have 4th root of what? 2x on the inside. Alright? What about a 162? That's 81 times 2. That's 3 times 3 times 3 times 3, right? I skipped over to 9 times 9, sorry about that, but we've seen that earlier from earlier example. So 3 comes out of that from the 4 of a kind. 4th root is looking for 4 of a kind, right? So simplifying can be tricky for 4th roots here. And the x stays inside as well, right? So you're going to have what? 6x also turns out. So 6x here. So 2x times 3, right? 3 coming out, so that's going to be 6x times the 4th root of 2x. So again, they're like terms with 2x's as the radicand. 6x plus 6x is 12x times the 4th root of 2x. So this is the solution we're looking for right here. Alright? So again, not too hard if we simplify the radicals carefully. Combining like terms is really the easy part here. Alright? Let's focus, let's get to multiplication here, because that's certainly more challenging. Let's go and clear out the screen. Let's take a look at something like the cube root of, let's say, 4, let's make it, 4x squared y cubed, alright, times the cube root of 40 x y to the 5th power, right? Now, if you recall from square roots in the past, we've done similar problems with square roots, right? Since the root index is the same and you're timesing the 2 radicals together, just put it under one big radical, one big cube root, and have 4x squared y cubed times the 40 x y to the 5th. All right, that's going to be the cube root of what? 4 times 40 is 160. All right, 160 x what? X squared and x, that's going to be x cubed. Y to the what? 3 and 5, add the exponents, right? So y to the 8th. All right. Let's simplify this cube root then. So make sure we're okay on that. Again, just put under one big cube root, multiply the 2 radicands together. You get 160 x cubed y to the 8th. Now we just simplify this cube root to finish out. That's going to be 16 times 10, if you will, which is going to be 4 times 4 times 5 times 2. So you got 2. Let's see, 2 times 2 times 2 times 2 here for the 2 4s, and the 5 and 2 here. So I'm just looking for 3 of a kind here, right? So I only have 3 2's here. I can't really take anything out from these 3. I need to multiply them back together. So I can take a 2 out. 2 comes out from there, right? And what else? Well, x cubed, I can take out one of the x's. There's no more x left inside. What about y to the 8? Well, 8 divided by 3, take the power divided by the root index, right? That's what? That's going to be 2 remainder 2, isn't it, right? 8 divided by 3, so you can take out 2 y's, y squared, and you're going to have y squared as well left inside. So you're going to have what? 2xy squared on the outside, and then the cube root of what? What's inside? 2 times 5 is 10, times 2 is what? 20. So you have 20 for the number. What else? Y squared. Alright? So this is the solution we're looking for. So simplifying can be tricky, but the theme for multiplication is just multiply the radicans if the root indexes are the same. Alright? No big deal here. What about a problem like this we've seen in the past? Let's take a look. Let's go back to a square root problem. What about we have something like square root of y times the quantity square root of y plus the square root of x. Alright? Well, this is nothing more than using the distributive property to distribute this radical y, this square root of y. So root y times root y is going to be root y squared, right? So just multiply the two radicals together again. Root y times root x is going to be what? Root xy. Alright, no big deal there, distributing. And what's the square root of y squared? That's just y though, right? And then you can't simplify that, just bring it down. Okay, so that's our solution. But one thing I want you to see from this is that a radical, well, root y times root y, which was what? Which simplify all the way back to y. In other words, a square root times itself is just whatever's inside in this case. So we can skip this step right here and just put down y if we wanted to for the second step. All right? Just a little side note there. Okay? Let's try another one here. Let's do some more square root calculations. Speaking of square roots. All right? Let's take a look at something like this one. What about 3 square root of x plus 2 square root of y times, ran out of space. Let me just do it on a different screen. Sorry about that. I don't have enough space here. Let me go and clear out the screen here. Let's try this one. So let's look at 3 square root of x plus 2 square root of y times 5 square root of x minus 9 square root of y. Okay, so we've seen something like that in the past. That's a y right there. All right. Think of this. Think of the FOIL method, right? Think of distributive property, right? Draw 2 arrows on top, 2 arrows on the bottom to distribute, and then finish off the problem by combining like terms and what have you, right? So let's do that. So let's distribute this radical term to both of these terms here. So 3 root x times 5 root x. That's what? That's 15x, isn't it? Because again, a radical x times itself is just x. Root x times itself is just x, in other words. Square root of x times itself is just x. All right. What about 3 square root of x times 9 square root of y? So 3 times 9 is what? 27. So minus 27. Okay, sorry, Sketchpad's acting up a little bit. Minus 27 square root of xy. All right. So 2 arrows on top, now 2 arrows on the bottom, distributing the 2 square root of y. 2 root y times 5 root x is going to be what? 10 root xy. And 2 root y times 9 root y, that's going to be minus 18, right? 2 times 9 is 18. Again, root y times itself is just y. Okay, so make sure we see that though. All right, these are like terms in the middle, so we combine them. So final answer is 15x minus what? 27, negative 27 plus 10, negative 17 square root of xy minus 18y. So distributing, we get these results. Let's try another one here. Take a look at 4 root 2 plus 3 root, let's make it root 10 times 5 root 2 minus 2 root 10. Let's go and try this one. So get 2 arrows on top, 2 arrows on the bottom. So 4 root 2 times 5 root 2 is going to be what? 4 times 5 is what? 20. Root 2 times itself is just 2. Okay, so make sure we see that now. Okay, so again, you can show a step by saying root 2 times root 2 is root 4, but root 4 is what? 2. All right. What about 4 root 2 times 2 root 10? That's going to be minus 8, right? 4 and 2 is 8. So multiply the outside with the outside and inside with the inside. 2 times 10, this 2 here times this 10 right here is going to be what? Radical 20, square root of 20. All right. How about 2 arrows on the bottom? 3 root 10 times 5 root 2. That's going to be what? 15 square root of 20, right? 3 times 5 is 15. 10 times 2, 20. Again, outside would multiply with the outside. Coefficients times the coefficient. Radicand times the radicand. All right. What about the last multiplication there? That's going to be what? Negative 6 for the coefficients. And what? Again, root 10 times itself is what? Just 10. Or root 100, but that's going to be 10. All right, so make sure we see that and skip that over that step right there, right? So again, a square root times itself is just whatever's inside. All right. Anyways, let's finish it off. 20 times 2 is going to be 40. These are like terms here, so negative 8 plus 15 is going to be positive 7 square root of 20. And 6 and 10 is going to be 60. All right. Now, we can simplify the 20 as well. 4 times 5, right? So what comes out? 2 comes out. So you can have 40, first of all, 40 minus 60 is what? Negative 20 there for the two numbers here, constant. And the radical term is going to be what? 7 and 2, 14 square root of 5. Okay, so pretty involved problem, as you can see, involving the FOIL method for distributive property. But I think we've seen this somewhere in the past. So just work it out carefully in terms of the calculations. All right. Let's go ahead and look at a few with formulas, perhaps. Right. Let's try this one here. Let me go and clear out this. Let's stay focused on square roots here for a moment here. What about something like this? Or how about 6 square root of 3 plus 4 square root of 2 quantity squared? All right. Well, we can use the formula we had in the past of a plus b quantity squared, can we not? That's going to give me what? A squared plus 2ab plus b squared, right? That was the formula we had for this perfect square, right? So what's my a here? Use the same formula for this problem. My a is the first term, 6 root 3. My b is simply the second term, 4 root 2. So if I apply the same formula and I square the a out, what do I get? Well, I get 6 root 3 quantity squared. That's a squared, right? That's my a squared. Plus what? 2ab. Let's do the 2ab calculation on the side. A times b is what? 6 times 4 is 24. 3 times 2 is 6. But you got to double that, right? 2 times 2, right? When you double that, you don't double the 6, you double the 24. You double the coefficient only. So that's going to be 48 radical 6. So you get 48 root 6, right? Square root of 6, plus b squared, right? B squared. That's 4 root 2 squared. So this is going to be 4 root 2 squared. All right? So you're going to get what? 6 squared is going to be 36. You get root 3 squared is just 3, so times 3. Plus 48 radical 6. And what's 4 squared? 16. So 16 times what? What's root 2 squared? 2. So this is 108 plus 48 radical 6 plus 32 for 16 and 2. 16 times 2. So that's going to be what? 108 plus 32 is what? 140. 140, that's a 4 right there. Sorry about that. 140 plus 48 square root of 6. All right? So again, just work it out carefully using this perfect square formula, and we get the result. Same thing for the other perfect square formula. Let's go and try this one. Take a look at 9 square root of x minus 7 square root of y quantity squared. All right. Now we're using the other. Let me squeeze that in here. A minus b squared formula. This was what? A squared. Instead of plus 2ab, it'll be what? Minus 2ab. Still get the positive b squared at the end. All right. So it's very similar formulas to recall here, right? So again, my a is what? 9 radical x. Again, if you don't want to use the formula, just write it twice and draw the arrows out as we did earlier for FOIL method. But it's better to use the formula, saves us some time. 7 square root of y is my b. So a squared is what? That's going to be 9 square root of x squared. 2ab, so that's going to be what? 63. 9 times 7, square root, that's a 3 there, sorry about square root of xy. I need to double the 63, so I get 126 if you double the 63. Square root of xy, double the coefficient again, right? Double the 63 only, not the xy. So that's the 2ab in the middle here. So minus 126 square root of xy plus b squared, that's going to be 7 root y squared, so 7 radical y squared. So this is what? 9 squared is 81, root x squared is just x, minus 126 square root of xy, 6 right there. And 7 squared is what? 49y. Root y squared is just y. So we have this result as our solution here, using this perfect square formula. So apply the formulas, right? Let's look at another one. What's the other formula? Well, how about difference of squares formula? What about something like 5 root 2 plus 3 root 7 times 5 root 2 minus 3 radical 7. So this is of the form a plus b times a minus b. Let's recall what that is. A plus b times, that's a b there, sorry about that, times a minus b. Well, that's just difference of squares. A squared minus b squared. You simply square the first term minus the square of the second term. So my a is in this problem is going to be what? 5 radical 2. My b is going to be what? 3 radical 7. Okay, so always identify a and b if you can use the formula. So a squared minus b squared, that's going to be what? 5 radical 2 squared minus 3 radical 7 squared. Alright? So what do we have then? Well, I'll just work it out. 5 squared is 25, right? A squared minus b squared, as mentioned, right? So 25 squared is 25. Root 2 squared, again, is just 2. Right? Radical 2 squared, the square roots and the square cancel each other out, so you get 2. Minus 3 squared is what? 9. Root 7 squared is going to be just 7. Alright? So make sure we see that 3 squared is 9. Root radical 7 squared is 7. So 50 minus 63 are what? Negative 13. So when you use this difference of squares formula, notice the answer is just a number without any square roots. No more square roots remaining. Right? Let's go ahead and try this one then. What about 4 square root of x minus 3 square root of y times 4 square root of x plus 3 square root of y. Okay? So again, a minus b, a plus b, same formula applies. So my a is going to be 4 root x, my b is going to be 3 root y. So again, a squared minus b squared, 4 root x squared, a squared minus b squared, 3 root y squared. So this is going to be 16x minus what? 3 squared is 9, 9y. So again, when you apply this difference of squares formula, there's 2 square roots. There's no more square roots remaining in your final answer. All right? When you have this relationship where you have a product where there are no more square roots remaining, that means that these two quantities you're multiplying here are called conjugates of each other. Let me give you that definition. Let me go and clear out the screen. So let me say that the conjugate of square root of a plus the square root of b is simply the square root of a minus the square root of b. So just change the sign from plus to minus. And they are conjugates because, so when you multiply two quantities that are conjugates, again, you use that difference of squares formula we had earlier, and you end up with an answer that no longer involves a square root, no longer involves a radical expression. All right? Keep that in mind because let's get to division here. All right? So how do we divide divide two radicals here? Well, for example, let's say we have something like the cube root of 60 x to the 4th power divided. Let's look at division here. So divided by the cube root of 5. I'm sorry, of 5. Let's say. Sorry about that. Cross that off. 5x. All right. So that should be 5 right there. So erase that part of it. So this, if you are dividing two cube roots, again, just put it under one big cube root as we did earlier for multiplication. 60x to the 4th over 5x. Can we see that? So this is going to be what? Simplify that. 60 over 5 is 12. So this is going to be the cube root of 12x cubed. Can we see that? And you can't really simplify to 12 in terms of the cube root because we can't get 3 of a kind in there, so that stays inside. But the x cubed, we can take an x out of that. So you're going to have final answer x cubed root of 12 as our solution. But again, just put it under one big cube root for division here. All right. What gets more tricky is that when you have a cube root on the bottom but not on top. Here's what I mean by that. let's say you have something like, let's make it 10 divided by the cube root of 5x. So we have something like that. So how do we carry out this division? Well, in other words, how do we get rid of the cube root, get rid of the radical symbol on the denominator? Well, in the past, for square roots, you simply have to times the same thing to top and bottom. But this is not going to work for cube roots, because we need a perfect cube inside to cancel this root index out. And that means what? Now, well, I have one 5x inside. If I can get two more 5x's inside, then I can cancel out the root index cube root. So how do I make that happen? Well, if I multiply to top and bottom by the cube root of 5x squared, right? That will get me two more 5x's inside. Can we see that? Because what is that going to give me? First of all, on top it's going to be 10 times the cube root of, now cube root of 5x squared, I can't take anything out because I don't have any triplets in here, right? So I'm just going to square this out. That's 25x squared. You with me so far on that, right? 5x squared is 25x squared on the top, right? But on the bottom, can we see that this product is the cube root of 5x to the third power? Can we see that? Because if you take 5x times 5x cubed, don't you think of this as 5x to the first power, right? 1 plus 2 is going to be 3. Now you have the third power, you can cancel it with this root index. So this is going to be 10 times the cube root of 25x squared all over what? Just the 5x. Can we see that after you cancel the cube root with the cube? So now that's the fraction we have left, so I got rid of the cube root on the bottom, but I still have to reduce it because 5 into 10 goes 2 times. So final answer will be 2 times the cube root of 25, sorry, squeeze that 25 in there, x squared running out of space, 25 here, that's a 25 there, all over what? Just x. Alright, can we see that solution there for this division problem? Let's try another one, give us a better feel for this. Let's take, for example, let's see here, what about 6 over the fourth root of 3y. 6 over the fourth root of 3y. Alright? So I want to get rid of this fourth root on the bottom here. Now to do that again, I need a perfect fourth root inside. So and 3y is in that. So how many more 3y's do I need? Well, I'm going to need what? 3 more of these guys. So I'm going to times by the fourth root of what? 3y cubed, because I need 3 more of these guys to get a perfect fourth power, on the denominator. So times by the fourth root of 3y cubed here. That's a 3 there, alright? So that will give me what? 6 times the fourth root of, now let me cube that out since nothing will come out here, right? Since I'm looking for 4 of a kind, and I certainly don't have that here. So, but what's 3y cubed? That's 3 cubed, 27y cubed on the inside, for the top. On the bottom, what you have again, just like we had earlier, we now have 4 of these 3y's. 3y to the fourth power. Can we see that? Because you have 3 here and 1 here. Total is 4 3y's. So we can cancel that with the fourth root index. So you're going to get then what? 6 times the fourth root of 27y cubed over what? Just the 3y's left inside. Again, reduce it. 3 into 6 twice. You get 2 times the fourth root of 27y cubed all over y on the bottom. And I got rid of the radical on the denominator. All right? Can we see that? So pretty tricky if the root index is not 2 or square root. If it's square root, just times it by itself, and that will work every time. But if the root index is 4 or 5, make sure you get enough powers down there to cancel the root index. You want to match the power here with the root index, right? Bottom line. Okay, then let's finish off with 2 terms about going back to square roots here. What about something like this we had here that we might have seen in the past? Something like, for example, 4 plus root 2 divided by 3 minus root 3. Okay, how do we divide this out? Well, we want to get rid of this square root on the denominator. And if you recall earlier, I wrote down the definition of conjugate. When two conjugates are multiplied, it will get rid of the square root. So what you want to do for a problem like this is you want to multiply to the numerator and denominator, so I would say to top and bottom, meaning numerator and denominator, by the conjugate of the denominator. Alright, that's the key concept. So you want to times top and bottom by what? 3 plus radical 3. So let me do that on a new screen here. Let me go and clear this out. So earlier problem, let me just recopy it. 4 plus root 2 divided by 3 minus root 3. So to simplify this, let me start the process here. 4 plus root 2 times 3 plus root 3, conjugate of this denominator, over 3 minus root 3 times 3 plus root 3. So essentially I'm multiplying to top and bottom by the same thing, right? Just the conjugate of the denominator. So I'm not changing anything. But I do have to FOIL out the top. So 4 times 3 is going to be 12. 4 times root 3 is going to be what? Now don't say 12 again because this is inside, this is outside. So don't mix the two. So it should be 4 radical 3. Can we see that for the second multiplication? Alright. Likewise here, 2 root 3 times 3. Do not multiply 3 and 2. 2 is inside, 3 is outside. So it needs to be 3 outside, 2 stays inside. Alright, can we see that? And what about times the last term? Well, this time they're both inside, so I can times them together. Radical 6, right? 2 times 3. All over what? Well, this is a minus b, a plus b, so my a is 3, my b is what? Radical 3, or a squared minus b squared. So that's going to be 3 squared, a squared minus what? B squared, so radical 3 squared. So this is equal to what? This is equal to 12 plus 4 radical 3 plus 3 radical 2 plus radical 6. I can't do anything here. There are no like terms to combine. Just bring down these terms. Can we see that? All over the what? 3 squared is 9. Root 3 squared, again, square root and square cancel each other off, so minus 3. So the answer is going to be what? 6 right here on the bottom. So can I reduce this fraction? No, I cannot, because these coefficients don't have anything in common in terms of a common factor. So final answer is simply going to be pretty long. 12 plus 4 root 3 plus 3 root 2, that's a 3 there, sorry about that, plus root 6 all over 6. Alright, so think conjugate when you have a problem like this here. Let's go and try one more to finish out and give you some problems to post into Blackboard. Let's go and try root 2 plus root x divided by root 2 minus root x. Okay, how about a radical expression divided by its conjugate? Well, again, you want to times to top and bottom by what? The conjugate of the denominator of the bottom, right? So this is going to be root 2 minus, I'm sorry, not minus, plus, excuse me, sorry about that, I lost my train of thought there, but again, what's the conjugate of the denominator, right? Not the numerator, right? So sorry for the confusion here. So it should be what? Plus right here, right? Plus root x, and same thing to top and bottom, root 2 plus root x. Right? Again, times by the conjugate because you want to get rid of the radical on the bottom line. So this will give me what? Well, the top is really what? This thing square, right? This is really root 2 plus root x squared, which I could use the perfect square formula for. And this, we can use the what? The a squared minus b squared formula. So root 2 squared minus root x squared. A squared minus b squared, right? As we saw earlier, right? My a being root 2 again, my b being root x. If you think about the formulas a little bit. Alright, anyways, let's square this out very quickly. What's a squared? This is my a, right? A squared is just 2. What's a times b? Root 2x. See, a times b is root 2x, right? You can multiply these two guys. They're both inside. But you doubled only the outside right here. So what's the outside? Well, it's an invisible 1. So you double it, you get 2 root 2x. So you get plus 2 root 2x plus b squared is just what? What's b squared? Just x. All over, that's going to be 2 minus what? X here, right? Can we see that? So 2 minus x. So this is the final solution of this division problem. Alright, so a lot of work here obviously in this section, but do the best you can. Alright, let me give you some problems to try and post into Blackboard to finish out. Let me go and clear out the screen. Alright, so number one, I want you to simplify these 3 problems here. We have 4 times the cube root of 54x to the 7th y cubed. Alright, minus 3x times the cube root of 128 x to the 4th y cubed, alright, plus 6x squared times the cube root. I'm running out of space here, but hopefully you can see it. 2xy cubed. 2xy cubed there. Sorry about that, running out of space there. So this last one should be 6x squared cube root of 2xy cubed. Alright? So simplify these radicals and combine like terms, bottom line here. Alright, number 2, let's use the formula for this one. 9 root 6 minus 5 root 2 quantity squared. Use that a minus b quantity squared formula for this, or write it twice and FOIL out, but we prefer the formula here. And division here, think conjugate. 4 minus 2 root 5 over 2 minus radical 5. So 4 minus 2 radical 5 divided by 2 minus radical 5 times top and bottom by the conjugate of this denominator to simplify. Alright, so try this out, post the answers into Blackboard, and then we'll go over it. Until next time.